It's
How you
Shannon and
doing?
Ralph.
Howdy, Ralph.
I'm up.
It's good to see you.
Likewise, at least your photo.
You can, oh, you just see the photo?
Just got your photo, yeah.
Good, because I'm eating.
Okay.
Well, there's Susan. Good.
Hey, hi.
How are you?
Good, welcome.
We're going to record this, Matt. So when we're done, I'll send you a link to it so that you can share it yourself. Okay?
Perfect.
Okay.
I'm gonna put a timer on, make sure I don't get too deep. Put a timer on, make sure I don't go too grossly long.
So, do you want to take questions as you go, or do you want to go for it and then take questions?
I think it might be easier to take questions at the end.
Okay.
It might be, I wouldn't be surprised if there was some lively discussion, honestly. And we're certainly, we're as a team at CSI, we're definitely keen to hear ideas and suggestions about how to move forward and develop more hydro in Wallowa County. So we definitely are looking for feedback from folks.
Okay.
Howdy, Kyle.
Well, people are, what time is it? What have we got?
Hey, guys.
Is it? Oh, it's just 12 now. We got to wait a couple minutes. People are still hustling on there in Wallowa County time.
Yeah.
Hey, Rich. Hey, Matt.
How you doing?
Hey, Cheryl. I don't know if anyone else is on. Oh, there's plenty of other folks on. SPJ, Joe, Tara. Howdy, guys.
Hi.
And for those of you who just got on, Cheryl said she's going to punch the record button once Matt starts. So, and then we'll have that up there so people can click on it. Then you won't ever have to do it again, Matt. You can just
Just play it for the people.
yeah, you can retire. Just
But that doesn't give me the opportunity to get better.
Let's give you an opportunity to get better now. Matt King with the Wallowa Resources, and the program today is Hydropower in Wallowa County. It's on a split screen here, so you can check who's watching it with you over to the side and watch the presentation. And he just said, we'll go with the presentation and then open to questions afterwards and comments. Have at it, Matt. There you go.
Thanks, Rich. So just before we get started, I just wanted to introduce our team at CSI. Joe Basil is on, Tara Porter is on, and Matt Jones. They're all on. Cole Lathrop he does a lot of our engineering work. He's not on. And we also have Kyle Petrosini on. He was the program manager for about half a decade and is now with the University of Oregon and still very much supports our work. Little introduction to CSI in general. So I'm sure most everyone on the line is familiar with Wallowa Resources, but CSI Community Solutions Inc. is the for-profit subsidiary of Wallowa Resources, and we focus on renewable energy and biomass utilization with a couple of other activities. We manage some campgrounds down in the Inaha corridor as well, or the maintenance of the campgrounds. But basically, our mission is to provide business consulting services and create new businesses that can generate benefits for the community and for the environment. And that's really played out in this renewable energy development. So we, just in terms of the existing renewable energy in the county, we have about 6.6 megawatts of renewable thermal and electrical, and that includes heating for houses. So we use a lot of biomass heat in Wallowa County, as everyone's familiar, all the wood stoves and whatnot, and projects like the enterprise school boiler and there's some pellet boilers that we have at the old hospital at the Wallowa Resources building. And all those renewable resources and the solar and the existing hydro account for about 25% of the county's total energy demand. So we're actually pretty darn clean and green around Wallowa County, and a lot of that energy is sourced locally. So a lot of the, especially the biomass thermal, and then certainly all the solar and hydro is all locally owned and operated and using local renewable resources. That amounts to about $5 million retained in the local economy. So it's definitely more than a drop in the bucket. It is a fair amount of savings that are generated for the community by owning our own energy resources. Generally, our goal at CSI is to generate all of our own thermal and electrical energy here in Wallowa County. If we did that and those projects were locally owned and operated, it would represent about $20 million a year that would stay in the local economy. So that's a pretty substantial chunk of change and represents about 8% of the total economic output of Wallowa County. And there are a lot of other benefits that I'll get to later around local projects. But first, I want to talk a little bit about the history of hydro in Oregon, because it's pretty darn interesting. So the very first transmission project in the world was actually at Oregon City, at Willamette Falls, and it was in 1889. Is about 1,000 horsepower unit that were AC units, so alternating current, invented by Nikola Tesla. There were some smaller systems that were invented by Edison that were DC, that did some little streetlights around Oregon City, but the Willamette Falls Power Project actually exported electricity 14 miles to downtown Portland and turned the lights on in downtown Portland for the first time in 1889. And that project garnered in an era of hydroelectric projects, not just in Oregon, but honestly across the world. That being said, this is all about electricity generating projects, and hydro has been around ancient times. So people have used water moving downhill to generate power, especially to move grist mills to grind grain, for thousands of years. So hydropower has been around for a long time. You could argue that it's actually the lowest or the first source of energy, the longest running source of energy generation. Bonneville Dam, I'm sure everyone's familiar with that. The first major dam on the Columbia River. It was completed in 1937, and it really brought power to rural areas across Central Oregon and Central Southern Washington, and the whole dam building effort from the Bonneville Power Association up the Columbia River really turned the lights on in rural Oregon and rural Eastern Washington. So it provided power across the Pacific Northwest. Just a little bit about the mindset. So a lot of people think about the problems that have come from building dams and hydropower in general. Reservoirs inundating salmon habitat and all the problems around fish passage. And sometimes it's hard to remember what the mindset was of folks when they were actually developing all these projects, both small projects like we had here in Wallowa County, but also big projects like you see on the Columbia River. So really, rural areas, they didn't have irrigation and they didn't have electricity. And so these big dams allowed not only for the immediate job creation following the Great Depression in the early 30s, but the Rural Electrification Act was specifically designed to turn the lights on in rural communities. And so people could really get behind that. And all the benefits of electricity and moving away from, burning coal and oil lanterns and whatnot. And there's a fun little bit of history on the Columbia River dam system. Woody Guthrie actually wrote an album. He was paid by the Bonneville Power Association to write an album in support of the development of the Columbia River dams. And it's it's a pretty interesting piece of music where you have this person that's heralded, this folk artist that's heralded as sort of a resistance artist, and talking, many of his songs are about being anti-fascist and Nazism, but being wholeheartedly in support of the development of these dams, and wrote a number of songs that reflected that. A little bit of history of Wallowa County specifically. So this picture of Joseph from 1910, you guys can all see that there are all these power lines running everywhere. And so it's pretty amazing to think that far back, and even before the Bonneville Power Association was building the big power dams, that Wallowa County was actually electrified. And it happened, within 20 years of the first major system going in Oregon City, that all of the towns in the valley, so Joseph, Enterprise, Lostine, and Wallowa, all had their own small generating facilities, and they basically just ran lights and powered factories, and they were all paired with existing textile mills and flour mills. So in places where you already were using hydropower for turning looms to make textiles, or turning grist mills to make flour, they basically would just use that same shaft and that same infrastructure, add a belt to a generator, and then be generating electricity. So in 1910, this was all a project from a company called Joseph Power and Light. Wallowa Lake Dam went in 1920. There are a couple different timber crib iterations right around the turn of the century, but this picture is of the completion or near completion of the dam. And when it went in, certainly the main purpose was irrigation of the upper valley, and serving what is now the Associated Ditch Company ditches, or actually now the Wallowa Lake Irrigation District. So the idea was to store water for irrigation of over 16,000 acres of ground in the upper valley, but it created opportunities for hydropower production. And miss it out of order here. And so you can see here that this is an old picture from about 1923 that was part of the water right application. And this is the Associated Ditch Company dam. I'm not sure if you guys can see my cursor. So this is the end of the lake. This is where the new dam was. There's actually a 48-inch wooden pipe that ran down to this old powerhouse that's right next to the city park where the new playground is. There's still a brick building there where the old powerhouse was. And when that was put in, that was really the first project that was big enough to power multiple towns. And so that actually served power to Joseph and Enterprise when it went in, and it operated all through to 1958. So it operated and was able to provide ancillary power throughout the county till 1958, when it was actually struck by lightning and it caused a fire and burned down, and they never rebuilt the plant. The other one that's been around since the 20s, and it was built by Enterprise Electric Company, not to be confused with Enterprise Electric and Rentals as we know them now. But it was built, and actually between those two plants, so between Wallowa Falls, which is still operating, everyone that's been to the head of the lake, you can see that project before you go hike up up the Wallowa River, and it's between the Wallowa Falls Hydroelectric Project and the City of Joseph Hydroelectric Project. They were able to power all of the electricity needs for Wallowa County up until about 1950. And at that time, so over nearly 30 years of electricity generation in the county was served exclusively by locally generated hydropower. And then in 1953, the Bonneville Power Association built a number of transmission lines across the Pacific Northwest, and were able to serve electricity to Wallowa County, which worked out because that was right before the Joseph plant went offline. And at that time, they decided Pacific Power had actually already purchased the Wallowa Falls hydroelectric plant, and they decided to keep that online as ancillary power as needed. And it's been operating and serving as ancillary power ever since. But when the Joseph plant shut down and we got power from BPA, that sort of ended a lot of the smaller projects that were around, and they're a lot harder to get details on, but there were a number of smaller projects around the county. So a little bit about the current status or recent history of hydropower. So this modern building down here is the Big Sheep Hydro Project. It's up by Fergie, and it operated up until the 90s on water from the Big Sheep Ditch. So if you've ever been up to Salt Creek, that ditch that goes right by moves water from Big Sheep into the Upper Wallowa Basin to serve irrigators right in the Upper Valley. And so that hydro project operated for many, many years. And at times between that project and a couple of others on the line, they were able to serve all the electricity demand in Wallowa County with the Wallowa Falls project. So there's still, from the 1920s to the 1950s, all the power in the county came from local hydro. And then at times, even up until the 90s, there were moments at least when all of the power that was being consumed in the county was being generated locally. This photo up here is a dedication ceremony. You can recognize some of our local officials, John Hillock and Susan Roberts, and then that Senator Hansel, dedication of our project that Wallowa Resources Community Solutions manage the development of on behalf of the county that's serving their water district up at the head of the lake. So you guys can go see that project. It's located at the state park, at the Wallowa Lake State Park. And it basically takes water that's serving a domestic municipal water system, so just drinking water for the community at the head of the lake, and offsetting the cost of pumping up there. And so that project should save the county somewhere around $17,000 a year in electricity costs. This turbine down here is the second turbine in a series down at SPS of Oregon, which is Vern Spar's business and land between Lostine and Wallowa. And he's got two projects that CSI has facilitated down there that are currently operational, and each of those generates about $5,000 a year. So there are current projects that have been put in the last 10 years, and many others that we've been working on, and some that have recently been decommissioned, and projects like Wallowa Falls that have been operating for 100 years now. So a little bit about kind of the basics of hydropower opportunities, and what you really can use to make hydro. So existing municipal water supply infrastructure. So we're talking about basically drinking water and city water systems. Oftentimes those water sources come from springs up on a hill, or are pumped up to a tank. And in those cases, when you have water running down a pipe downhill and into a domestic water supply, there's opportunities to generate some hydropower. Irrigation infrastructures, similarly, a great opportunity for hydropower development, especially in the context of irrigation modernization. So currently across the West, there's a realization that the water resources that we have enjoyed for the last century, since these ditches got put in, and even century and a half in some cases, may be impacted by changes in the climate. And there's an understanding that the water in stream has a substantial amount of value to aquatic resources, especially places where there are salmon. So the more in-stream water, the more benefit there is to species like salmon. At the same time, we know that agriculture is the backbone of rural communities across the West. And so we need to ensure that irrigators and agricultural producers are getting an adequate amount of water, while also trying to create benefits in stream to those aquatic resources in the face of what could be a more limited resource all the time. One of the solutions for that challenge is what we call irrigation modernization. And basically it's a matter of taking open ditches and flood irrigation systems and putting in pipe and pressurizing things and allowing irrigators to deliver a more precise amount of water to crops, so that the crops get exactly how much they need, and then only diverting exactly what is required to meet that need, and then leaving all the rest of the water in stream. And it eliminates, by putting it in a pipe, you eliminate seepage out of the ditch. And in a lot of cases, and just to take Wallowa County as an example, when a water supply analysis was done a couple years back for the county, it was estimated that half of the water that's diverted into ditches is lost before it is delivered onto a farm. And so that represents a lot of water that could be left back in stream. And so understandably, there's a huge push towards those irrigation modernization efforts. And one of the other benefits from irrigation modernization is energy conservation and generation. And so the conservation side comes from situations where farmers are pumping out of an open ditch to serve their irrigation needs. And by putting that water in a pipe in a place where there's topography like we have here in Wallowa County, you generate pressure, and then you eliminate that need for pumping. It's estimated that in the Upper Valley alone, in the Wallowa Lake Irrigation District, there's something like $500,000 a year in pumping costs that could be eliminated by piping. So there's a huge benefit in terms of energy conservation. And then there's a huge opportunity in hydro generation. So you can take that same pressure, and where the pressure that's generated by putting water in a pipe exceeds the needs of a farmer to run their irrigation systems, you can actually take down some of that pressure, similar to a pressure reduction valve. But instead of just eliminating that energy like a pressure reduction valve, you can capture it through a hydropower project. And so we're seeing a number of different project opportunities come out of irrigation modernization efforts that are happening here in Wallowa County and elsewhere across the state and really across the West. The other big project opportunity that we're seeing in Wallowa County right now is high gradient springs. So we live in a place where there are lots of springs that come off the side of a mountain. And in some cases, those are already being put to a beneficial use, either irrigation or drinking water. But in some cases, they're not. And in most cases, there's not really a impact on fish or especially salmonids. And you can leave water in stream, take a little bit out, generate some hydropower, minimize your impacts, and those are good opportunities for hydropower development as well. And interestingly enough, before the Wallowa Falls and the Joseph hydropower projects were in the 20s, there were a number of small hydropower projects on high gradient streams that had gone in or were planned. I've been able to find about a dozen water rights that were issued between 1890 and 1920 for hydropower projects on high gradient springs across the slope of the Wallowas above the valley. Just real quick, some examples of projects that don't work. Low gradient streams, you really need to have a substantial amount of fall. And so low gradient streams where water is just moving along are not really suitable for hydropower development. Flood irrigation systems are not really suitable. And then to justify the cost of the infrastructure and the development and the interconnection to the grid and all that stuff, you really want to make sure that you have a year-round flow, or at least long enough flow like you would see in a 150-day irrigation season to justify putting that project in. So a little bit about the markets for hydro. We're past the days where we're spinning a grist mill to make flour. And so the markets in current times are really net metering, which is similar to when you put a solar panel on your roof, and that offsets your electricity costs on a one-to-one basis. Power sales, where you actually just export electricity to the grid, and the power company buys that electricity from you and pays you for that delivery. And then there are some future opportunities that we're looking at that should create some good opportunities to market the power that's generated from hydro. Particularly, there's an effort underway to develop a hydro-specific tariff or a renewable-specific tariff for Oregon that would allow power to be sold somewhere between the power sales price and the net metering price. So that would definitely help open up some markets for the electricity that's generated. Generally, among these, net metering is the best value because you get a one-to-one credit on any power that's generated. So you save electricity costs. You're not selling it, so you have to have a power appetite that you're offsetting, but it's offset one-to-one. So that's generally the highest value. Power sales is certainly the lowest value. The way that power companies set the price for power sales is what they call the avoided cost rate. And they set the avoided cost rate by the cost of putting natural gas in an existing gas plant, more or less. And so especially where the price of fossil fuels is low, power sales don't generate a lot of income. And then those future opportunities would fall somewhere in between. And so that's something that we'll look forward to as they come. And certainly, as we all know, energy markets are changing, and there are lots of efforts around moving towards decarbonization of our energy system, and that'll certainly open up opportunities to market hydropower. So the markets are great, and a project has to pencil to be able to be developed. No, these aren't projects that are something that we as a hydropower developer would pursue if there wasn't some sort of assurance that there's a good financial return. But more than that immediate market return on the hydropower that's generated, there are some real values beyond. And so one of the biggest things is that when energy projects, whether they're hydropower or solar or biomass, when they're locally owned and operated, those dollars stay in the local community. So when a hydropower plant gets built on an irrigation system that serves a half dozen farmers, those farmers are the ones that actually reap the benefit and save money on their power bill. And then those dollars stay in the local community. They can be used for maintenance of that irrigation infrastructure. They improve the bottom line of agricultural lands and farmlands, which also has an impact on the conversion of farmlands from agricultural production to subdivisions or second homes, and so it creates a financial driver to keep those lands in agriculture, even if it is a small one. Then it kind of impacts this broad topic of community resilience, and so that speaks to a number of different values. Obviously, the economic resilience part. The more municipalities and individuals and farms are supported in their bottom line, the longer they'll be able to operate, the more sustainable their farms and township budgets and individual operations, whatever it may be, will be. And then just generally, the more projects that are developed, the closer we get to sort of creating an economy around renewable energy, which sort of feeds itself. Once we have enough projects that we need to have a full-time staff member to operate them, then that's another job in the county. And then all of a sudden we're providing workforce education and training new people how to do that, especially creating opportunities to train youth to operate hydropower systems, or to install solar systems, or to eventually do grid balancing and energy storage. And so by creating these sort of economic drivers for renewable energy, you can lead towards a whole economy that ends up with this education piece and job creation and that community resilience as a whole. There's also this emergency piece. So none of the projects that have been developed thus far can necessarily have a direct impact on emergency resilience, but a system of hydropower and solar and storage projects could allow essential services to remain powered in the case of an emergency, whether it be a catastrophic wildfire or even a public power safety shutoff, where the utility decides to shut off power for some reason, as has happened in California, or some sort of catastrophic flood that shuts stuff down. So there's having your own generation assets within the county allows for at least the potential to keep those emergency services powered in those times of emergency. And then there's also this environmental benefit. So, there are projects where, especially if you look at the context of irrigation modernization, where, you're supporting a farmer's bottom line, you're delivering them pressurized water, you're creating an opportunity for hydro that benefits their, their savings on their electricity bill. But then you're also helping create drivers to put more water back in stream and actually do the project and pipe it and create benefits for salmon. In some cases, a little bit of energy generation is what it takes to move a project along and help realize those environmental benefits to fish. And obviously there are some more global benefits to regenerate or to generating carbon-free energy. And so, the more green electrons we can put on the grid, and the less coal that we have to use, the better. So that's it. I only went a little bit over. Hope it wasn't too long for you guys. But I'd just like to open it up for questions, and thanks everyone for listening. Any comments that anyone has about, or suggestions about potential projects? Our team at CSI is always keen to hear any ideas anyone may have. So don't be shy.
So Matt, could you speak to the current outreach and scoping study that CSI currently has underway?
So we are engaged about 10 years ago. The Freshwater Trust, Energy Trust of Oregon, and Renewable Energy Solutions, which is the sort of the precursor to Community Solutions, Inc. Those three organizations teamed up to do a scoping study of hydropower potential on irrigation systems in the county. And they identified several project opportunities, and including the 2 projects that have been built and are operating on Vern Spar's property. The environment has changed a lot, and technology has changed a lot. The permitting and regulation side has changed a lot in the last decade. And so with the support of Energy Trust, we are engaged in an effort to collect sort of a comprehensive list of all of the potential hydropower within Wallowa County today, as well as future opportunities associated with irrigation modernization efforts, and recreate that scoping study. And that's an effort that is ongoing, and we will be working on for the next year, really. So yeah, we really want to be able to identify all the potential so that we can determine which projects are the low-hanging fruit, and focus on developing the easiest projects first, and accelerate the pace of hydropower development in the county. That outreach and scoping effort will also be a part of what we hope to be a countywide energy plan that would be sort of technology agnostic. So we wouldn't just be looking at hydropower. We'd be looking at all energy sources, including solar, biomass, geothermal, energy efficiency, transportation. So that's perhaps going to be the next phase of our countywide energy analysis.
So Matt, what's the for the low end in terms of the small end of things? What kind of capital investment are you talking about? How does that compare to solar capital investment for output? And what are the subsidies for a farmer or a irrigation district or whatever? What are the helps there?
So that's a great question. Generally, when you talk about a solar installation, you're looking at about $1 a watt, and something around a 4 kilowatt, 5 kilowatt project should offset the average household in Wallowa County. In the case of hydro, it's a little bit more than that. So there's not really a good metric in terms of dollar per watt for hydro, because it's so project specific and so site specific. So it's not deployable in the same way as solar is, which makes sense because the sun shines everywhere other than in the shade, and so it's much more standardized. But for example, we're looking at a project right now that would offset one home effectively. That is, it should cost somewhere around 30 to 40,000. If we looked at the Wallowa County Service District project, that project was about 200,000, and we'll save $16,000-17,000 a year. There also are really good incentives for hydro. So as many of you may be familiar, there have been great incentives for solar, but some of those incentives are sunsetting. And hydro, because it's a baseload resource and doesn't have the intermittency day-to-day that solar does, there's been a lot of interest from the USDA, especially the Rural Energy for America program, and the former Oregon Department of Energy Renewable Energy Development Grant Program, which we hope will be renewed in some form, but has sunset at this time. And then certainly Energy Trust has been incredibly generous in moving these projects forward. And they, in terms of funding agencies, Energy Trust of Oregon has been instrumental in moving irrigation modernization projects along in situations where they conserve power, and then also moving hydropower projects along. So the incentives are good. Generally, we like to think about it in terms of just a return on investment. So we really only develop projects that can get a return that's less than 10 years, if possible, and try and get enough grant funding to do that. And one of the differences with solar and hydro is that hydro turbines have a lot longer lifespan generally. And so there are, the project at the service district, for example, the pipe that we put in for that project should last 100 years. The turbine should last at least 25 and perhaps up to 50. And at that time, it will just need a new runner, which is a small, relatively small cost when taken into account the whole project. So there's it is a long game, and even a 10-year return on investment isn't good enough for your average investor trying to make a buck. But these projects really do have a solid longevity.
Hey, Matt, you mind if I jump in real quick?
Yeah.
Yeah, Matt got to it, but I was going to say, Rich, levelized cost of energy is kind of a good metric to look at when comparing the different technologies for energy production. And hydro still has some of the lowest levelized cost of energy. That means over the entire life of the project that it's still making each kilowatt hour at the cheapest amount, right? So Matt spoke to the history of hydro. As long as these projects don't, and didn't get burned down as the City of Joseph project, or they can be kept running for 100 years, as the Wallowa Falls project has been. So hydro is still, and also the benefits of it being baseload. I think Matt spoke to that, that it can produce power day and night, as long as the resource is there. So when we're talking about irrigation, we're talking about sort of seasonal production, but it's still considered baseload, because even during irrigation, you're running it day and night as water is being sprinkled on the fields. So yeah, just wanted to jump in there, and then also say, as Matt introduced me earlier, I work for Energy Trust. I ran the CSI program for 5 years prior to Matt, and I just wanted to, for those of you who are not familiar, Energy Trust invests public purpose charge dollars from the investor-owned utilities, so Pacific Power out here. Invest those public purpose charge dollars into renewable energy and energy efficiency. So businesses, municipalities, residents can access those programming, all those different programs for energy efficiency measures and incentives, as well as renewable energy projects. So I'm still working in the hydro realm for Energy Trust, and we are thrilled to continue to provide support specifically for irrigation modernization hydro. So that's sort of hot and heavy right now, and for the foreseeable future is upgrading the infrastructure of our irrigation infrastructure in the West, and where we can, making them highly efficient, capturing all the loose streams of energy that are out there. So we are thrilled to continue to support Wallowa Resources in its mission to develop and expand the hydro market, specifically in Wallowa County. So nice job, team.
Yeah.
Thanks for letting me jump in.
Thank you,
So,
Kyle.
So Matt, you've got some questions that I think are really relevant. One is about plans to put irrigation water through pipes to avoid water loss. So a lot of that's been done, so you could speak to that. I also have the financing, and then how that is relevant to fish protection.
So
Are
Can
there,
I add? I'm sorry. Can
Yes,
I?
if you want to look at the chat.
yeah, I just opened up the chat box. I wasn't sure that I could do that while sharing my screen too, but so one of the questions Elnora asks, when do you think we could generate all of our own energy in the county? So from a technical standpoint, I think that we could do it pretty quickly. I think one of the biggest challenges is figuring out the best means to integrate with the existing utility and the existing grid without encumbering projects with interconnection costs that they can't afford. And that actually gets to another question that was asked was, will you be discussing the challenges in adding more generation to the system? This is a very big subject that needs to be addressed so residents are correctly informed. And that's absolutely correct. So that's, back to the first question, I think we will be able to generate all of our own energy within the county when we really can figure out the best way to address this interconnection challenge. And there's the PUC, the Oregon Public Utilities Commission, is putting a lot of work in right now and has several open dockets around how these projects move forward and how community energy is developed, so that those other benefits of community energy projects can be realized, while also ensuring that the utility continues to be able to provide reliable delivery of electricity. And so, yeah, it's certainly a challenge. I'm hesitant to put a number out there for when we could actually get there, just because it is a big question around what to do with interconnection. And I think maybe what that I can't tell who the commenter was, but I think they might be referring to situations where even folks that are just installing solar on their rooftops have been denied because of the lack of available capacity. And really what that all gets down to is that, when Pacific Power built the grid in Wallowa County, and this is true for utilities everywhere, it really was meant to be a one-way delivery of power. So all the substations, all the transitions from high voltage transmission lines to the distribution side, which is where the actual users are, all the businesses and houses and everything, that was really a one-way street. And when you look at these distributed generation projects, you're talking about making it a two-way street. And so there's a lot of engineering and equipment that goes into making that happen. And so we're very much in the midst of figuring out how to address that right now, as is the Oregon PUC, as are communities, across the country. Another question, are there concrete plans to put irrigation water through pipes to avoid water loss? If so, how do we find the money to do that? Yes, absolutely. There are a number of different efforts going across the county, being led by Farmers Conservation Alliance. And FCA is a group out of Hood River, Oregon, that they basically do design, engineering, and implementation for piping projects. And their whole business model is designed to deliver farmers the water that they need to run successful agricultural businesses, while also putting water back in stream and benefiting fish.
I'd like to jump in there real quick as well, Matt. So yeah, and currently in Wallowa County, it's being done segment by segment. So the Wallowa Lake Irrigation District just finished a piping project on the North Prairie Pipeline, so the far kind of northern end of Prairie Creek, and the lake water that's delivered out there was there was a water loss assessment done and found that a lot of water was being lost into the ground in that section. And then you've got the evaporation as well. And so that's been a highly successful project to get online. Took a bunch of pumps offline for irrigators on that section in the North Prairie area. And yeah, it's putting more water back in the stream. So yeah, there's definitely no concrete plans right now to pipe all the irrigation in Wallowa County. It's being done piece by piece in the sections that make the most sense currently. And of course, Wallowa Resources and Energy Trust are right there, also looking for hydro opportunity with all of that work as well. So.
Absolutely. So Nora asked who's financing the irrigation water and pipes. Energy Trust of Oregon, USDA is doing a lot of different irrigation modernization projects. In some cases, foundations are involved. So like the Freshwater Trust has funded piping projects. And then in some cases, there are enough financial drivers with groups of irrigators themselves, especially when they're getting pressurized water and eliminating pumping costs, that farmers can fund a significant cost of the upgrades, and they often also contribute income. The other piece is that, in some cases when you're creating savings by piping and putting those water savings back in the river, you can create what's called a certificated in-stream water right or conserved water right. And in that case, different organizations like the Freshwater Trust can actually buy that water right. So that guarantees that that water isn't put to some other use, that it's guaranteed in stream. And farmers are, in some cases, like Woody Wolf's project, where all the new pivots are between Lostine and Wallowa. He was able to retire effectively and put in stream a number of CFS of his water rights, so a significant volume of his water rights to help pay for the project. But because he went from flood irrigation to pivots, he just needs a lot less water. So he's actually able to deliver more water to his plants when they need it, while also relinquishing some of his water rights, which can be certainly a controversial topic. But if you look at Woody's operation, it's been a real win-win for him and for fish.
Matt and Kyle, a few years ago, several years ago, there was a project to put a whole bunch of water into pipes in the upper valley and take it down to the lower valley. And you think about all of how the landscape has been changed by ditch digging and irrigation channels, and also of course, by the channeling of streams and making them, which we're now trying to reverse with meander, right? So there's it's kind of a real complicated deal, isn't it? I mean, this piping is it's one more human hand on the water system that we've already been meddling with for a long time. And do we know all the consequences, I guess, is the question.
Yeah, absolutely. I mean, the water infrastructure, as well as the live water bodies, the streams and lakes and everything is really a built environment. And you can't move away from the human hand in all of those instances. The streams, the ditches, the lake, all that stuff has been impacted. And so I think our challenge now is to find where we can create the most benefit with the least intervention, and not say, hey, we messed this all up, so we got to just get rid of all the ditches or something like that. And in a lot of cases, like the ditches are a great example. They've been around for 150 years. They're 150-year-old cottonwoods that create habitat for hawks and whatnot along them. And so finding ways to minimize those interventions and the impacts of those sorts of modernization efforts, while also still being able to realize the benefits around energy conservation and irrigation water delivery, and especially the in-stream water benefits. And so that's where there's not like a blanket solution. We shouldn't pipe everything, but some stuff should be piped. We shouldn't remeander every stretch of stream, but some of it should be remeandered. And so really just being diligent about evaluating each situation individually is really important.
Thank you. Hey, we've got time for one or two more questions.
I've got a quick couple comments, Matt. I just wanted to jump in and say that our utility out here, Pacific Power, they're absolutely a partner in this work as well. So Pacific Power provided a grant for the Wallowa Lake Service District project that's at the head of the lake. Matt had pictures of that earlier on in the presentation. So through their Blue Sky grant program, they provided a grant for that project, and we've gotten excellent support from Pacific Power out here to help the development of these projects. There are a lot of challenges, as Matt referred to, the interconnection issues that we are bumping up against, the feeder, the actual distribution line capacity issues. So we've got a lot of work ahead of us, but we're absolutely not going to be able to do this without Pacific Power. So they're a huge partner, and I wanted to recognize them for that. Also, just a quick comment on funding for piping. Matt mentioned NRCS, so federal funding. If a ditch is organized into a district, and then they go through a process of getting a watershed environmental assessment study completed, and that gets reviewed by NRCS and approved, and there's everybody agrees that there's no significant impact, then a project can become eligible for PL 566 as a federal funding source. And just to give you an idea, Farmers Conservation Alliance has been successful in bringing to date about $170 million of federal funding to Central Oregon for some of these exact piping modernization and irrigation modernization piping projects. And once the pipe gets put in the ground, then we can also look at creating hydropower. So we are absolutely, maybe a step behind that, but yeah, there's a lot of interest in modernizing irrigation infrastructure and, of course, generating local, clean, distributed, real energy.
Yeah, and then just to reiterate that too, like the Pacific Power has provided reliable, affordable electricity in Wallowa County for over 100 years. And unlike some communities elsewhere, like down in California, where they're like, get the utility out of town or something, that's not what we're talking about here. We definitely see Pacific Power as a partner in this effort, and I think that Pacific Power feels the same, that we can work together to find ways to work through these interconnection issues, and I am working with our colleagues at Pacific Power certainly on a weekly basis to address some of that stuff, and so we're keen to find solutions, and certainly see Pacific Power as a partner. Any other questions before we wrap up?
Well, I would just interject that if you do know people who have, streams running across their property, or they've got water rights, or they have a spring on their property that's, delivering water, moving water without fish, to check in with Matt or Joe at Energy Trust. They've got an online questionnaire that, is the first step in sort of beginning to understand whether or not a project is possible. And, they're happy to talk with anybody. And just call Wallowa Resources and punch the appropriate button.
We love talking hydro or solar or biomass or any other sort of renewable energy.
Okay. Any last questions or comments? Thank you very much, Matt. And as I said, this will be recorded, or this has been recorded. So Cheryl will send you the link, and I'll have it too, so I can send it back to you, Matt, and I'll put the link out also to the Friends of the Library here, so it'll get out there and it'll get watched that way. Okay.
Thanks, Rich, and thanks everyone for listening.
Okay.
Thanks.
Bye-bye.
Thank you, guys.
Thank you.
Bye.